Here we have a typical direct online motor starter control circuit. I've done this on the Zelio Soft 2 software, and it's actually running in the simulation mode at the moment. Now I've programmed my e-stop and my local stop and my remote stop as normally open contacts. The reason I've done that is that in the field they are actually normally closed contacts. So by programming them as normally open, when the PLC goes into the run mode, they will then go true. As it scans those normally closed contacts, it will actually put a 1 in the input registry for those particular inputs. I just noticed that I had that one turned on. Let's turn that off and turn that off and turn that off. So let's give this a little run and see how it performs. So I'm going to activate, because this is simulation, I have to force these closed. So I've just brought my e-stop true. Now I'm going to bring my local stop. Then I'm going to bring my remote stop closed. Now I've got an overload. The overload hasn't tripped at a stage, so I'll just put this ready closed so the motor can start as soon as it gets the local start switch command. So my local start switch, this one here, by the way, I forgot to label it, is actually going to be my remote start switch. So this particular program has got a remote stop start built into it. So just for your reference, stops and safeties always in series, and starts and latches always in parallel. So here I've got my local start, in parallel of that I've got my remote start, in parallel of that I've got my latch. I'm using an internal relay here that's going to be energized once I hit my start switch. So now my internal relay M1 is true, and I've got a contact that closes off internal relay M1, which is a normally open contact. That's now true, and that brings on my output, actual output, which is Q1, which is going to control the motor contactor coil. And I've got a running lamp, which is also now on, which is addressed to Q2, which is going to be probably a green lamp that shows that my motor is running. Okay, so everything's going well. I'll just sort of pull back a little bit, and we can see now that the motor's running well. It's happy with everything running. But let's see what happens if I have an overload situation. So say, for example, this motor is driving a pump, and say the pump, maybe the filter gets blocked and the pump starts to become quite difficult for the motor to drive, and it starts to have an increase in current. That could operate the thermal overload and trip this out. So now that's tripped, it's knocked off my M1 internal coil, and it's knocked off my contact off M1, which has opened the contactor Q1, and also the motor running lamp is off. And when that comes off, I have to actually operate this because I don't have the overload connected to the PLC. This is like a flip-flop arrangement, so 95, 96 go open, and 97, 98 go closed. So this goes closed, brings up my overload tripped lamp. Possibly I could have an audible alarm in parallel of that to maybe a siren, letting us know that this particular motor has now tripped out on overload. So very easy little program to write. In simulation, I don't have any real inputs and outputs connected to this, so that's why I've had to intervene to simulate the operation. So documentation is fairly straightforward. Oh, hang on, I have got that there. There we go. I just forgot to actually click it open. So that's a little feature on Zelio. Just remember that. You can hide the addresses. So back through to the actual programming of this, starting off from the rung here, so from the rail here on our first rung, our first input here is our E-stop for emergency stop. Then we've got our local stop switch. So this is just an operational, these two are just operational stop switches. This one here will be the mushroom emergency stop, which is only activated in the event of an actual emergency taking place. So those three are in series with the thermal overload contact. And these here, of course, in parallel. Just stop it for a moment. Bring that closed and knock that one there off as well. So it's all in its sort of rest state at the moment. Just the E-stop is closed. These here, of course, will all be normally closed in reality in the field. And just waiting now again for that start command. So coming up to this point here is just a series of normally open contacts. Then we've got our first lot of starts, and in parallel of that we've got our normally open contact, which will go closed when the internal relay M1 goes true. So this contact there is actually off this internal relay. Also off the internal relay M1 is yet another contact, which is going to drive our Qs, which are our real outputs. So on Zelio it uses Q for outputs and it uses I for inputs, and M's for the internal relays or auxiliary relays. So fairly straightforward, very easy for you guys to pick up on this if you want to follow through on this code. Just go to the Snyder website, download a copy, latest version of Zelio Soft 2, go into the editing mode under ladder, and you should be good to go. Also for documentation, it's a good idea to put a few rung comments. Just gives you an idea of what's going on. See if I can bring it up a bit. There we go. So this first rung here, this rung is for the E-stop, stops, overloads and starts and latch. Then down here I've got another comment. This rung here has the internal bit controlling the motor coil and run lamp. And then on the last one I'm saying this rung here is for the overload trip lamp. So it doesn't hurt to put a few comments there on the rungs. If somebody else opens up the program, they've got some idea of what you're trying to achieve with your code. Okay, thank you for viewing this. Hopefully it's given you some inspiration to get on to doing a bit of basic PLC programming, and I'll catch you a little bit later on in another video.